Transformed logarithmic functions, C2. Given a graph of transformed exponential or logarithmic function for which you need to write an equation, how can you be sure that the graph is exponential or logarithmic? Part B is write an equation for the given graph. Now in this series of communication questions, we are trying to understand the basic logarithmic function. Rather, we are trying to get the picture of this logarithmic function. Most of my students are doing logarithms for the first time, and so my emphasis here is to see it, to understand it, then be easy to get it. So this question here is, when you see a function, how can you decide that this is an exponential function or a logarithmic function? So that is sometimes a confusion with some students. So let me clear this first, right? So let's look at both the functions, right? Here I'm trying to sketch both the functions, right? So we'll do exponential function and also sketch one logarithmic function. Exponential functions look like this, correct? And the logarithmic function, which is inverse of exponential, right? Kind of which gets reflected on this line, right? Looks like this, right? So that is how log and exponential functions look like. So this is exponential. Let me take a concrete example, like 2 to the power of x here and log to the base 2 of x here, right? Just as an example. So that is an exponential function. That is, and this is my logarithmic function. So what do you notice? In exponential function, domain has no restriction. Do you see? What is the domain here? That x belongs to real numbers. But here, domain is restricted. X has to be greater than 0, correct? So that is one very major difference between the two. Second major difference which can be observed from the graph is about the asymptotes, right? So the second major is asymptote. So you have a horizontal asymptote. Do you see? Horizontal asymptote. That is important. Horizontal asymptote. And it is normal basic function will always be at y equals to 0, correct? And here we have a vertical asymptote, and that will be at x equals to 0, correct? So that is your vertical asymptote. Do you see that? So let me just mark this a bit for you. So this is your horizontal asymptote for an exponential function and a vertical asymptote for logarithmic function. So these two characteristics will guide you whether you're writing equation for an exponential function or for a logarithmic function, okay? So that is the answer for part A of C2. Now let's try to write down equation for this graph, correct? So when you look at the graph, these are the critical things we are looking at. So first thing, we are looking at domain and range. Well, domain is restricted for this function, and therefore this should be a logarithmic function, correct? So let me start building my equation here. So we'll say it is a log function, okay? Not a bad idea. So we're just trying to write down rough things here, then we'll come up with our final equation. And now it's a log function. That's perfectly fine. And first thing we see, let's compare with this kind of a log function, right? I'm not saying this base is 2. I'm not saying that, right? But just a log function, okay? Now it seems, well, it has flipped. It has flipped. That means there is a flip vertically, right? Along the x-axis. Therefore, there should be this minus thing before the log thing. So we get that minus. That denotes reflection on the x-axis, correct? So we got that reflection, correct? And what else do we observe? We observe the critical thing. Where is the vertical asymptote? So, well, the vertical asymptote is kind of moved 2 units to the right, correct? It is not here. So where it is? It is here. So that is my vertical asymptote. Do you see that? So that is the vertical asymptote, and we say, well, this is my vertical asymptote, and this vertical asymptote is at x equals to 2, correct? That is the value of the vertical asymptote. So 1, 2, 3, 4, 5, correct? So this is that 2. So that means that my function has moved 2 units to the right. So we can write like this and say, well, x minus 2. That is my vertical asymptote shift. Good job. So we've done half of the equation, correct? Now let's look into the other point, and that is, where is this x-intercept? Well, even if I flip it, do you see, x-intercept will remain there itself. And it is always 1 unit away from my vertical asymptote. So if I go 1 unit away from here, from vertical asymptote, so that point I see it is not here, but it has moved 1 unit up. Do you see that? So my x-intercept, which should have been 1 unit away from the vertical asymptote, right, is not there. It is 1 unit up. That means this has moved or translated 1 unit up. So I'll write plus 1 for that. So plus 1 shows that there is a vertical translation of 1 unit up. That's a good thing. So we got at least 3/4 of the equation covered. Now what? Now we have to decide what should be the base of the function. To find the base of the function, in this case, if it is log to the base 2, then if I have, what is the value of log 2 of 2? Log 2 of 2 will be 1, right? So that means 2 units away there will be 1. So I'm looking for y value of 1. So what has happened to the y value of 1? So if it has moved up, then that value must have been down here, right? Since it is reflected. Reflected means going in the opposite direction. What I observe here is, so that is the value. This is a good point to check. So what I check here is that, what is this point? This point is at 12, right? So if I write x as 12, then I should get 0, right? The x-intercept. How can I do that? So let me put x as 12 in my equation, right? So what I will do now is plug in 12, this value of 12, and try to get y equals to 0. So let me write y equals to something which I don't know what about. Then if I put 12 here, then what do I get? To get a 0, this should be 1, right? Because minus 1 plus 1 will give me 0. Now 12 minus 2 is 10, log of 10 should be 1, and therefore my base should be 10. Do you understand? Therefore my base should be 10. So this point confirms that my base is 10. I hope you get how I found the equation of my graph, correct? So let me summarize this for you. So first point which we'll consider is reflection, correct? So we considered reflection. So this was a reflection, right? Critical points which we observed here and wrote our equation is reflection on x-axis, right? Reflection on x-axis gave this point, minus. Do you see that? And second, we observed that the vertical asymptote moved 2 units to the right. Second was vertical asymptote translated, right? 2 units right. And that gave us this parameter, x minus 2, translated 2 units right. And then we checked the value where it was 1 unit away from the vertical asymptote. That was at x equals to 2. So we checked the value at x equals to 2 plus 1. Let me write 2 plus 1, which is 3. And we found that was 1. But we should expect that to be x-intercept. It was not x-intercept. So that means it gave us a result that there is a vertical translation. Correct? Of 1 unit up. And that gave us our next result, plus 1. Do you see that? And how did we get the base? We got the base by checking one of the values. And that was kind of a very significant value for us, and the present x-intercept we saw. We observed that the x-intercept has changed, right? And that helped us to find or figure out the base 10, correct? So that is how we found equation of our graph this time. But anyway, any graph equation given to you, any function, exponential or logarithm given to you, the critical parameters which you need to observe are, vertical asymptote, x-intercept, a value beyond 1 near the x-intercept, correct? So near the vertical asymptote. So these are the values to check and get your answer. I hope you understand and appreciate it. So finally, we get our answer, and our answer is, let me write down here, y equals to minus log to the base 10. So we should not write 10 here, right? X minus 2 plus 1. So that is the equation of the given graph. Correct? Thank you.